Let's learn about our atmosphere. In this video, we will learn about the extent of the atmosphere, the composition of the atmosphere, processes in the atmosphere, the division of the atmosphere, which are the troposphere, the stratosphere, the mesosphere, and the ionosphere, and the International Standard Atmosphere. What is an atmosphere? An atmosphere is simply a layer of gas that surrounds a world. Why do we have an atmosphere? The gravitational attraction between two objects depends upon the mass of both objects. Jupiter has large mass, so it can hold much lighter gases. Earth has less mass than Jupiter. Therefore, it has lost most of its lighter gases and kept heavier gases. The Moon has too little mass to hold any gases, thus it has no atmosphere. Now let's talk about the Sun. Solar energy as radiation provides heat, light, and energy, which is necessary for all living organisms. Nearly 150 million kilometers separate the Sun and Earth, yet solar radiation drives Earth's weather. The Earth's heat balance is the way our planet regulates heat. Sunlight reflected off the Earth is called albedo. Black soil has about 10% albedo, and new snow may have 90% albedo. Cloud tops reflect light back to space. Cloud bottoms reflect heat back to the surface. Energy that enters the atmosphere as light needs to be about equal to the energy that leaves the atmosphere as heat. Otherwise, the Earth will go into an ice age or heat too much. Our next topic is the composition of air. There are different types of gases in the atmosphere, namely nitrogen, oxygen, argon, carbon dioxide, and other noble gases. The most abundant is nitrogen. Let's talk about the divisions of the atmosphere. The atmosphere is divided into four. Let's travel through the atmosphere and learn about these layers. Welcome to the troposphere. It extends from the Earth's surface to an average height of 36,000 feet. There is a temperature lapse rate of 2 degrees Celsius per 1,000 feet. All normal weather phenomena occur here. The tropopause is the upper boundary of the troposphere, and clear air turbulence may be present near the tropopause. The height of the tropopause varies according to the following conditions. 1. With latitude, the average equator height is 55,000 feet, with polar regions at 25,000 feet. 2. With seasons, as it's higher in summer than in winter. 3. From day to day. Now let's go into the layer above the troposphere. This layer is called the stratosphere. It extends from the tropopause to about 50 kilometers above Earth's surface. The temperature here lapses constantly with height. The air is very dry and there are no normal clouds, but sometimes mother-of-pearl clouds are seen here. Next, we look at the stratosphere and ozone layer. The thin ozone layer in the upper stratosphere has a high concentration of ozone, a particularly reactive form of oxygen. It's responsible for absorbing the ultraviolet radiation from the sun. This brings us to ozone in the atmosphere. It's essential in the upper stratosphere to filter ultraviolet radiation, which can cause skin cancer. And it's dangerous at ground level in the troposphere because if it's inhaled, it can cause damage to the lungs. It also erodes plastic, rubber, and some metals. Next, we'll look at the ozone hole. Chlorine from chlorofluorocarbons or CFCs is released from discarded or leaky air conditioners. Chlorine rises to the stratosphere and acts as a catalyst to break down ozone. Let's go into the mesosphere. It extends from 32 to 80 kilometers above the Earth's surface. Temperature increases with height to maximum at about 48 kilometers. then decreases to reach minimum atmospheric value at about 80 kilometers. ozone is concentrated from 16 to 56 kilometers. The last layer of the atmosphere is the ionosphere. It extends upwards from 80 kilometers. The temperature increases to extremely high values. Gases here are extremely tenuous and highly ionized. Radio waves are reflected from this layer and aurora forms here. Noctilucent clouds may occur in its lower layers. Interactions between the ionosphere and subatomic particles emitted from the sun excite atmospheric gases, causing the aurora borealis northern lights and the aurora australis southern lights. Let's move on to radio wave propagation. AM radio waves are long enough to interfere with ions in the sun-charged D layer. But at night, the D layer is weak, and the AM signal propagates further, requiring stations to use less power. Atmospheric processes: gaining and losing atmosphere. Gains: volcanic outgassing, impacts, evaporation. Losses: gas escape, impacts, condensation, surface reactions. Let's talk about greenhouse effect. In this process, infrared energy is re-reflected back to the ground by carbon dioxide. Next, we look at atmospheric circulation, convection. In this process, convection cells move gas from equator to pole and back. The Coriolis effect is a process that occurs when gas is dragged sideways by the rotation rate of the world. It's the way that a moving object seems to veer toward the right in the northern hemisphere and left in the southern hemisphere. Finally, let's talk about the International Standard Atmosphere. The International Civil Aviation Organization's International Standard Atmosphere, or ISA, provides a fixed standard atmospheric model used for many purposes, among which are the uniform assessment of aircraft performance and the calibration of some aircraft instruments. The model is akin to the average condition in mid-latitudes but contains the following assumptions. We hope you enjoyed traveling through and learning about the atmosphere.